Welcome minions back here to Nick Does Maths. I do believe that is still our channel. So today we are playing around with a first order differential equation. It's pretty nice, but we are being made to use a substitution for it. So let's have a go. Here's my differential equation. 2xy dy dx plus y squared is 2x minus 3x squared. There's a few things we can do, but first and foremost, what we don't have here is we can't separate the variables because we'll have y squares and x's all mixed up. And it's kind of tricky for us to find an integrating factor because there's a y and a y squared. Not absolutely loving life here. But the suggestion is let's use z is equal to x squared plus y squared. Let's see. Right. So let's differentiate it first and foremost to find out what dz dx is. Well, that is 2x plus 2y dy dx. Well, that's kind of handy actually because I'm not going to rearrange for dy dx because that's mental because I do have 2y dy dx right there. So if I rearrange this for 2y dy dx, I get dz by dx minus 2x. Should probably have a little look-see at our initial conditions here. It will be when x is 1, z is 1 squared plus 1 squared, z is 2. So what we're going to do is we're going to try and get this as z in terms of x. So let's start putting it all in. So I've got x times 2y dy dx, so that will be x times dz by dx minus 2x. Now, y squared, if we rearrange this, y squared is z minus x squared. And the right-hand side is 2x minus 3x squared. Well, let's multiply that out. X dz by dx minus 2x squared plus z minus x squared is 2x minus 3x squared. Woo! All right, let's not get too excited, everyone, but minus 3x squared minus 3x squared. So what we can do is we just need to solve x dz by dx plus z is 2x. Now, you might think, oh, integrating factor, but we don't need one. It's already there. This is, in fact, if you think of that as z times 1, this is, in fact, already a product rule. That is d by dx of z times x. So let's integrate. xz is x squared plus a constant. Now, I like to find the constant as soon as I can. So when x is 1, z is 2. So 2 is 1 plus c. That's going to tell me c is 1. So let's plug all of that in. Z becomes, divide everything by x, becomes x plus c over x. And z was x squared plus y squared. So y squared, z is x squared plus y squared. That is x plus 1 over x. So it's going to tell me that y squared is x plus 1 over x minus x squared. Skadoosh! Now, why on earth did we use this particular substitution? It was built to work, all right? We'll have a look at our next video. We're going to do this again, but in a slightly different one. So don't forget to hit the notification so you know when the sequel's coming out, when we're going to do this whole thing again slightly differently in the way I would probably have approached it in the first place. And yeah, subscribe as well. That way you'll get told. Drop us a comment if you can think of what substitution we're going to use ahead of next time. 'Twas me, Nick. Thank you for tuning in. Can't do this without you. Bye-bye.